Right. The software defined WAN is what our focus is. But before understanding software defined WAN, we need to understand software defined network, SDN. SDN is a general term, software defined network. In network we have WAN, we have enterprises or campus, we have data center. So when you are learning SD-WAN, it is not the complete SDN. It's just a portion. When we say network, we got enterprises network, means your office. You got data center. And we got wide area network to help communicate between campus and data center, between the data centers. We have internet, we have MPLS network, we have a cloud in the middle. So SDN, software defined network, is the overall terminology. If you take data center, we call their ACI. ACI is the software defined solution in data center. When you take campus, means enterprises, we call it as SDA, which will be our next topic, software defined access. And in the WAN, it is SD-WAN. In the service provider or between the enterprises is the SD-WAN. All three together, SD-WAN, SDA in the enterprises for the campus, ACI for the data center. All three together is what SDN, software defined networking. Our focus is more on SD-WAN this training. It means in for coming days, SD-WAN. And in this training we will also be learning SDA. But ACI you will be learning only when you are enrolling for a data center. But what I am telling you is, all these three will have similar approach towards the network. Only difference is one is working for WAN, another one is working for enterprises, the other one is working for data center. But the approach towards the management, the configuration will be same for all these three, because basically it is coming under one topic called SDN, software defined. I want the network to be managed, configured, controlled, protected by software. And if I am focusing on data center, then it will be ACI. If I am focusing within the enterprises, then it will be SDA, software defined access. When I focus on WAN for software defined, what we have is SD-WAN. SD-WAN. So when we say WAN, forget about SD-WAN. When you say WAN, what comes in your mind? MPLS, VPLS, IP routing, point-to-point networks, or point-to-point connections, or virtual connections, point-to-point virtual connection using XConnect, something like that, VPWS. That's what comes in our mind, right? When we say, okay, there is also one more. When we say WAN, we will also have DMVPN for security. So when we say WAN, these are the things in general, classically, we used to consider. When someone says WAN, we think MPLS immediately. We think VPLS. We think IP routing between the sites, between different sites. One site is in Philippines, one site is in India, Bangalore. One site is in Lagos, Nigeria. One site is in Houston, US. Connecting between these sites is what WAN. We may use a layer 2 tunnel or layer 3 MPBGP or layer 2 VPLS. We may even have frame relay, whatever. So when we say WAN, these are the things that comes in our mind. For secure communication between the sites, we use DMVPN. Classically, this is how we were doing. Inside the campus, so this is about WAN. What about the campus, classical campus? In campus network, when you say campus network or when we say enterprises, what comes in your mind? So when we say WAN, we think about MPLS, right? When we say campus, what comes in your mind? OSPF, spanning tree protocol, Ether channel, and so on. Likewise, when you say data center, we have VPC, fabric path, vSAN, VLAN, FC, WWXN address, and so on. Now, the protocols are not the same for all these three. Yeah, maybe STP is there in all three, spanning tree protocol. Even OSPF you can see as a control plane protocol in all three. But there is big differences in the network design and so on in all these three. They are not going to be the same. So when you design a software-defined solution, when we are looking for software-defined data center and software-defined campus, that cannot be same because the consideration, the protocols are not 100% same. The expectation from the network in WAN and the expectation from the campus network is not the same. So with this itself, we can understand why we have three different software-defined solutions for these three type of networks. For campus, it is SDA. For data center, it is ACI. For WAN, it is SD-WAN. See, all these three type of networks have got control plane, data plane, management plane. You take campus network, depending on which device you are in, the control plane will be differing. Like if you are in switches, STP will be the control plane. If you are on the routers, the routing protocols like OSPF, ISIS is going to be the control plane. Likewise in MPLS, in WAN, you will have BGP, OSPF, MPBGP, route reflector. This all comes as a control plane. Likewise in data center. In data center we have fabric discovery protocol, ISIS or OSPF can also be used. So control plane is the one which controls the traffic flow. It is just controlling. It is just saying go this way, don't go that way. STP also does know. By blocking a port, what it does, it says don't go this way. If you go this way, loop will occur. So STP is a control plane in switching level. OSPF is a control plane. MPBGP is a control plane in MPLS tunnels in WAN. So this control plane is everywhere. Likewise, data plane is also in all these three type of network. What is data plane? The flow of data. Forwarding. Data forwarding. Flow of data. So in WAN also data flows. Campus also data flows. Based on the control plane decision, the data plane is determined. Data center also we have data flow. We have Ethernet data flow, FC data flow, fiber channel data flow and so on. Likewise, management plane is also in all these three. What is management plane? We do SSH to devices to do some configuration. We telnet to each and every device. If you take WAN, we telnet to edge device, ASR devices. We telnet to internal devices, maybe CSR device, ISR device. We SSH, we telnet. We use SNMP. Are we doing only in WAN devices? No. Even on campus network, we telnet to switches. We telnet to routers. So these three planes are seen on every type of network. In each type of network, in all these three type of network. In data center also we do telnet our Nexus device. Nexus 5000 series device, Nexus 7000 VDCs, we telnet, we SSH. So we have these three different type of network, and in each we have these three different plane: control plane, data plane and management plane. Why I am saying all this thing? Software defined solution should be aware of these things. The software defined networking, when we say it is not simple word, we are talking about all these three different type of network in one terminological software defined network. So this campus and WAN and data center, WAN, campus and data center are not same. They are three different type of network. Even though they are network, they are not same network. They are different They're different in design, different in protocol that they use. Even the devices there are different in size and capabilities. And all these three network types have got these three different planes. Control plane to control the flow of data as per the policy. Data plane is to forward the traffic according to the control plane's decision. Management plane is for you to log in, configure, monitor using SNMP, SSH and Telnet. So user traffic is everywhere, right? That's what data plane. User traffic is everywhere. It is there in WAN, it is there in data center, it is there in campus. Telnet, SSH, SNMP is everywhere. OSPF is in all three. ISIS, yeah, it is also in all three. You have seen ISIS in service provider. You have seen ISIS in enterprises. You have seen ISIS in data center. In data center, you may not be having ISIS explicitly, but all the features of data center uses this link state protocol ISIS. For example, Fabric Path uses ISIS protocol. So what I'm saying is, even though they all use some protocols in common, but some protocols are not in common, even though these three planes are seen in all these three networks, but these three networks are not same. Size is different, function means, the protocols are different, the traffic that they carry is different. Fine. So when we are talking about software defined, in what way software defined is better than the traditional way of configuring these three networks? These three networks, if you see data center or campus or WAN, you'll configure by logging into each device. Let's say you have a campus network. In campus network, you will have a lot of switches. And you will also have some routers. So in order to put RSTP, you need to telnet or SSH to these devices. So you enabled MST. Let's say you enabled MST by telnetting to each device. And you used to telnet to this device router and enable OSPF so that R1, R2 and R3 can form OSPF adjacency. R1, R2, R3 is forming adjacency because you got layer 2 in the middle, a loop-free layer, loopless layer 2 network because there is an STP working here. You have enabled maybe MST or rapid spanning tree. Let's not get into MST. You might have enabled MST or a rapid spanning tree. That doesn't matter. It depends on how many VLANs you have. We are not focusing on VLANs here. What I'm coming to say is, in campus you will have many switches and routers where you log into individual device to configure. If it is WAN, you will be having mostly routers. In WAN, you don't have much switching. If you take service provider track, you don't see switching topics in exam. Why? We don't have much switches in WAN side. All are ASR, CSR devices. So you will be logging into those CSR, ASR devices by how? Telnetting to each device, SSHing to each device. In data center also it's the same way. You are telnetting to each device. This is the traditional way of configuring data center, WAN and enterprises. But when we talk about software defined, we are trying to provide a centralized management system. Software defined network in ACI, in data center, ACI, we call it as EPIC. In enterprises, in SDA, software defined access, we call it as DNAC. In Sd-Wan, which is our focus of this class, we call it as Vmanager. Vmanager. That we actually now consider as virtualization, virtual manager. It's actually Vmanager Manager. Vmanager is a company which Cisco purchased. Now they call it a C manager also, Cisco manager. Vmanager, C manager, whatever. It's a manager, a controller. What it will do, it will help you to configure, control. It will help the Vmanager in WAN and the DNAC in SDA, EPIC in ACI. What it does, it helps you to configure, manage, monitor the network. If it is EPIC, you can manage and monitor and configure data center. If it is DNA, it is going to be your enterprises. If it is Vmanager, you are going to manage between sites. Between sites. What do I mean by that? You see, you got in Philippi, we got an office, so I call it a site 1. And in Kabul, Afghanistan, we got another site. And in Moscow, Russia, we got another site. And in Amsterdam, Europe, Netherlands, we got another site. In Stockholm, Sweden, you got 5th site. And in Houston, we got site 6. Let me call it a site 0. So let's say your head office is in Houston. It's in Houston. In India, this company don't want to come because of their lawyer, the honesty. They don't want to come inside India because the political people are very honest in India. So they don't want to come. They don't want that this type of honesty government. Anyway, let's get into this subject. So for some good reason, they did not come to India. They are everywhere. Almost 6 sites. The head office is in Houston. We want one place from where all these sites can be managed, configured. Instead of we going to Stockholm's edge router and inside LAN network or LAN device, likewise in Moscow, you got edge router and you got some LAN devices, some routers and switches inside Kabul. Philippines, Amsterdam. So you got edge device everywhere. The device that talks to the internet. Right? So we do not want to telnet or SSH or to any other one by one. We do not want to log into each device and configure. We want one single pane of glass. We want one centralized management place from where I'll be able to configure all these sites. Like Epic manages and configures the entire data center. Like DNAC does the configuration for all the devices inside a campus. We have a Vmanager which can configure. So we got Vmanager in the head office. Vmanage, not manager, Vmanage. In the head office, through which we will be configuring, managing all the edge device in various sites. That may be using MPLS, network. It may be using MPLS network, or it may be using simply IP network. Or you may have both. You may be using MPLS, so that Vmanager will go to all the sites, configure, manage them, or it may also use IP network. The reason why I'm saying, some people are saying that Oh, Sd-Wan, there is no need for MPLS. Those are all limited knowledge, understanding. So you may be having IP or MPLS. More detail we will discuss later. So I'm trying to say here we are not replacing here anything with MPLS, or we are not throwing out MPLS here. You may have MPLS or you may have IP in the middle. Fine. So what is the purpose of Vmanager? It is having the responsibility to make sure every edge device that connects via this MPLS or IP network registers, so that those edge devices can be configured and managed from this Vmanager. So all these edge devices, so this is another second component we are learning, edge device. Here in WebTailor they called as VEdge. 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 So all these VEdges should go to the Vmanager and register themselves first. VEdge. See, nowadays we don't call this as VEdge, we call it as C-Edge, Cisco Edge, or simply Vmanager. Vmanager. This is a nice word, better to use. But there is also some documents saying C-Edge. Early documents were saying V-Edge, WebTailor Edge. Later it became C-Edge, Cisco Edge. But now, even that is no more. We simply call it as Vmanager. Vmanager. That is the edge device that talks to the Vmanager. So this edge device need to go and first register to the Vmanager, which may be which is a software device, virtual device, installed on a virtual machine. So now this Vmanager may use Telnet or SSH or even netconf to communicate to the devices. So what is the protocol? Let's focus on netconf, SSH and Telnet. So Vmanager uses what? Netconf to communicate to the edge devices. Netconf. Netconf is the protocol. We can have more than one Vmanager. It is just a virtual machine, right? You may have another VM with another Vmanager, form a cluster. Form a cluster. For what? For redundancy. Yeah? For redundancy, you may have one cluster instead of one single Vmanager. Again, Vmanager is just a control plane for software defined WAN. Software defined WAN. I said, you need to answer these things when you are designing something through software. So one question is, one part is answered already. In software defined WAN, which one acts as a control plane? It is the Vmanager.
So Vmanager is management plane, right?
Vmanager is the correct. Right, vSmart is the control plane. I'll come to this in more detailed thing. To an extent, this is also doing some control job. But what our Ankit says is correct. Vmanager is a management plane where you use netconf to, not the control plane. Let's make it correct. It is management plane because you do what? Telnet, SSH, netconf. We are not using any protocols like OSPF or ISIS there as a control plane as an STP. So the management plane is the best way of saying Vmanager. Even the word says manage. Management plane. I appreciate. Because the routing part is not managed by Vmanager. Routing part is not managed by Vmanager. Just you will be logging into the remote device and configuring them. So it is very correct to say management plane. Vmanager is a management plane, not control plane. I said wrong. It is not a control plane. I said as control plane, it is not. Vmanager is a management plane. Like we used to telnet and manage each and individual device. Here we use netconf to manage every edge device using this Vmanager. Vmanager is a GUI through which we interact to all the edge device. So to connect to sites like Houston, Philippi, Kabul, Amsterdam, Moscow, the routing is needed. That routing is managed by vSmart. Understand? We need to have reachability, right, between these Vmanager and all the edge device. Someone needs to provide the reachability, the routing part. So the routing between sites is provided by or managed by, if I use the word manage, then it may again take you to management plane, and I'll say is provided by, facilitated by the vSmart. So far we are seeing the third V. First V is Vmanager, second V is Vedge, but I have not spoken much about Vedge. It is coming later. As of now, Vedge means it's an edge device of each site. That's what we have seen so far. Now, in order to provide reachability, the routing between the sites, please understand, routing between sites. Not routing between the Vmanage and the Vedge. Not routing between Vmanage and Vedge. Routing between sites. Means if a computer in Kabul tries to talk to a computer in Philippines, the route is needed. Only then the packet can go. There is an internet here. Vmanage is not in the middle. Vmanage is not in the middle. vSmart only provides the route information of Philippines. Let's say you have 10.1.1.0/24, 10.2.2.0/24 in Philippines. Here in Kabul, 10.3.0.0/24, 10.4.4.0/24. So these two routes are seen in the routing table of this edge, and these two routes are seen in the routing table of this edge is because of vSmart. It may be via an MPLS network, or it may be via internet. That doesn't matter for us. This is not our focus. So if Kabul can ping this 10.222, what does it mean? The edge device knows the route 10.2.2.2/0, 24, 10.1.1.0/24. If you want the reply packet, then this Philippine router should have the route to reach 10.3.0.0/24, 10.4.4.0/24. Otherwise the ping cannot happen. So to distribute the route between this two edge office in different location, vSmart is needed. vSmart job is to do the route distribution. The control plane between the controller and the edge device is a vSmart. Then why I am bringing controller in the middle, the Vmanager in the middle? Without Vmanager telling this, vSmart will not do it. So vSmart is the control plane between the controller and the edge device. Those who don't know DMVPN, just ignore what I am saying. Those who know DMVPN, you can imagine like NHRP protocol. The NHRP database is distributed is distributed across all the sites via hub. Likewise, vSmart distributes routes of one site to the other sites. From Amsterdam edge, you'll be able to reach Kabul and Philippines because the routes of Philippines is advertised by the vSmart to Kabul and also to Amsterdam. Likewise, the routes of Amsterdam is advertised to Kabul and Philippines, and Kabul's route is advertised to Philippines and Amsterdam by whom? By vSmart. That's why I said it's a control plane between the controllers and the edge device. So controller is very important for giving permission for all this. That's what we have as a Vmanager on the top. vSmart uses a protocol to do this. This distribution is not through OSPF or ISIs. It uses Overlay Management Protocol to do this. Overlay Management Protocol, OMP. This allows the edge device to send all the routes to all other sites. To the vSmart controller. So, what is the protocol between Vmanage and Vedge? Can someone say what is the protocol between Vmanage and Vedge? What happened? No. Vmanage and Vedge. Netconf. Yeah. Netconf. Now, what is the protocol between the vSmart and the Vedges? Is the OMP. OMP. OMP stands for Overlay Management Protocol. Overlay Management Protocol. So this vSmart is like a spine device in ACI, spine device in VXLAN EVPN, or if I need to put it simple, this vSmart is like a route reflector in BGP. So vSmart only takes the route of Philippi and reflects it. vSmart only reflects it to Kabul and to Amsterdam. That's why I say it's a control plane between the controller. What is the controller here? vSmart and the Vedge. The protocol that is used, it is used to distribute the route. The protocol that is used to distribute the route of one site to all other site is OMP. OMP stands for Overlay Management Protocol. Now, if you have done DMVPN, you answer this question. The spokes device, can they talk to each other without going through hub device in DMVPN? Answer is yes. But one spokes learns about other spokes through a hub. Likewise. Even here, Kabul can directly talk to Amsterdam. Even though the routes are distributed by vSmart, you no need to go always through vSmart. Not necessary. Sites can directly communicate. We have learned vSmart, a control plane, Vmanager, management plane. For vSmart, the protocol is OMP, Overlay Management Protocol. For Vmanager, the protocol is Netconf. This OMP runs between the vSmart and Vedge. Understand? OMP runs between vSmart and Vedge. Now this VH, about something about VH. We have seen vSmart, Vmanage. Now VH. This VH can be the device specifically sold by Webtail company, which is called VH device, or can be a CSR device, Cisco CSR, which is supporting now this feature, ASR, ISR. All these can be an edge device now. That is why we don't call anymore VH, we called as Vmanager. Or Cisco Edge. CH. CH or Vmanager. The VH terminology is gone. See, we got OSPF here. And we got OSPF here. This is the edge device of Philippines, this is the edge device of Kabul. This is normal routing or label switching provided by the service provider. This OSPF is not advertising these routes. Route 1, Route 2, they are not advertised by OSPF. Who is advertising the routes of one side to other? Someone tell me. OSPF, then why I have OSPF? OSPF is to just provide the reachability between Amsterdam edge to Kabul edge, Philippi to Amsterdam, Philippi to Kabul, just to provide the ping to the edge, reachability to the edge device. I have this OSPF, I have this MPLS, or I have this internet connection. If not OSPF, then what protocol carries the internal routes of Kabul to Philippi and bring the internal routes of Philippi to Kabul and Amsterdam? Tell me, which protocol? OMP. Very correct. It is the OMP that brings the route, that distributes the route of one side to the other side, to all other side. OMP. So you should not get misunderstood, like, OSPF is there, OSPF is going to advertise these routes. No. It's not like that. Just for reachability between edge to edge, you need to have some static connection or some routing protocol with MPLS or without MPLS. Whatever it may be, if you have reachability to the edge device, OMP can throw the route updates directly to the other remote edge without disturbing anyone in the middle. No one synchronizes, only the remote edges. So we have OSPF just for the reachability sake here. So we learned about this overlay management protocol, what it does. And then netconf, we have learned Vmanager, vSmart, VH. Now VH can be, or Vmanager can be, VM or physical device. We can also have a VM, or it can be a physical device. But VM or physical device. But the Vmanage that we learned, the vSmart that we learned, or VMs, not physical. Vedge can be a physical device or a virtual device, but Vmanage and vSmart are VMs. So we have seen three: Vmanage, vSmart, Vedge. Now what we are learning is the fourth one called vBond. See, this is the important portion of Sd-Wan. vBond is a device which can bond between, that's why it is called bond, vBond. Bonding means what? Combining. See, Amazon is a web page that forms a bond between the customer and the seller. Amazon knows me as a customer. Amazon knows Bosch as a vendor. So when I order a Bosch speaker, Amazon takes responsibility in between both of us. To me, it guarantees that Bosch is a good product. They will deliver you, don't worry. To Bosch, Amazon guarantees that Jay is a good customer. Don't worry, his money will be there with you once you deliver the product. How Amazon certifies me to Bosch and Bosch to me? Based on the certificate that they have about me. They have my bank detail, they have my phone number, they have my valid phone number because they send the OTP, and when I put the OTP it knows, okay, this is this guy. He is true guy. He gave a phone number and it is functioning. Based on the certificate about me that they have, based on the phone number and the bank credentials, they know me as a genuine customer. So with that guarantee, they can speak to the vendors like Bosch and make the business happen. Likewise, Bosch also, they know because it's a reported company. They also have a bank, they also have phone number that is registered with Amazon. See the bond. vBond securely makes the edge device to get registered with the vSmart and the Vmanage. Not every edge device can go and register with our Vmanage and get the routes of all the sites through vSmart. Then it becomes an attack. If an attacker brings an edge device and gets all the route of our other remote office through vSmart, then it is an attack. Internet is a untrusted public network. So what we are learning is over the internet, untrusted network. Not some network can be identified as our edge device. That's very dangerous. The real edge device of our company need to be identified and recommended to Vmanager and vSmart. Who does that? vBond. vBond only will give certificate. vBond only will say Fine, you are a genuine edge device. Now, this is what the Vmanager's address. This is what vSmart's address. Now you may go and talk to Vmanager and vSmart. Who does this? Vbond. Vbond only will show where the Vmanager and vSmart is. To whom? Vedges. Based on what? Based on the authentication. So, Vedges will not know about Vmanage or vSmart in the first place. They know only Vbond. Repeating again. Vedges knows only Vbond. How? Using a certificate, using an IP address. Okay, let's not get into certificate. Just put, no, Vedges will know the IP address, the fully qualified domain name of the Vbond. That is what we will be configuring on Vedge. In Vedge, we will configure only the address of Vbond. And we will say, Vedge, you go and talk to Vbond. Vbond will take you further. So, Vedges makes connection to Vbond using certificates, which I do not want to get into now. That makes Vbond to authenticate. That certificate that Vbond receives from the edge authenticates the Vedge and identifies the Vedge as a genuine one. Genuine WAN edge. Genuine WAN edge based on the certificate that is provided by the WAN edge. WAN edge is coming to Vbond and saying, hey, I am so and so. Vbond says, okay, I know you. Okay, fine. See, this is the IP address of Vmanager and vSmart. Now you can go to them and enroll. Go register yourself. Go. And then they will tell you what to do next. The Vmanager will configure whatever is necessary. Accordingly, you can go and have the control plane. So, from where all this starts is from the Vedge to Vbond first. Based on the certificate that is provided by Vedge, the Vbond authenticates and identifies the Vedge. Once the authentication is over, Vbond will allow the Vedge to know the address of vSmart and Vmanage. Vbond only allows the Vedge to or WAN edge to know the address of vSmart and Vmanage. Now Vedge can establish netconf for management with Vmanager and OMP with vSmart. Hope you understood the connection between all this. So Vbond is providing the bond between the edge device and the vSmart and Vmanage. With Vmanage and netconf, with vSmart, it's going to be OMP. But first thing is, all the V8 should get authenticated. Who is an authenticator? Vbond. Only after that, the edge devices will know the address of vSmart and Vmanager for management and for control plane. So V-edges are simply a data plane. V-edge or WAN edge is the data plane. Vbond is the security guard. security guard, security guard device, Vboard. And the control plane is vSmart. The management plane is Vmanager. Any questions so far?
So Vmanager is this service? Is this service or it?
Of course, it's a service that runs on the device to authenticate. Sd-Wan. So we will talk about Sd-Wan overview, initialize controller, initiating edge and C device. V-edge or C-edge are same. Using templates, we'll be configuring some policies, VPNs, centralized policies and advanced configuration. Let's see. Software defined WAN is a technology that based on SDN approach to centrally provision, manage, monitor, report and troubleshoot your wide area network. In order to have a centralized single pane of glass for all the sites like we saw, one in Philippines, one in Kabul, one in Moscow, one in Amsterdam. To have a centralized provisioning, manage, monitoring, report, troubleshoot, we need SD-WAN. So that helps to reduce the operational cost. See, if you can manage the sites from one place, you no need to have an expert engineer in each site. There is no need to employ many experts. Experts you need only on that centralized place. In our example, Houston. In Philippines, Kabul, in Amsterdam, in all other sites, you need someone who can just follow the orders. He need not to be an expert. See, the operational cost is reduced. Enable performance-based traffic engineering across multiple transports in your WAN. See, traffic engineering across. See, traffic engineering within one service provider is different from traffic engineering end to end. Only when we have end-to-end visibility, we can provide that end-to-end traffic engineering. This provides end-to-end visibility. Between all sites, you got visibility. Usually, traffic engineering is done by service provider for that autonomous system. Between autonomous systems, traffic engineering is not that easy. We do that using SD-WAN, sorry, not SD, using in segment routing, we do have a controller like this, and like what you have in Vmanager. There also we have a controller. And BGP LU will report from each autonomous system to a centralized controller, where you will get similar single pane glass view. The end-to-end traffic engineering is possible there. Likewise, here also you got a controller, a centralized controller, where you can have traffic engineering across multiple transport in the van. May have MPLS, may have IP, may have layer 2 MPLS, layer 3 MPLS. You can have very good traffic engineering end to end because you got visibility to all the edge device from one place. And very important thing that I want to say here is communication between the sites is not always via vSmart. Once the route is learned from vSmart, Amsterdam can directly talk to Philippi, and their communication will be IPsec capable, secured, provide security using built-in IPsec capability. The communication between the site is IPsec. Alright, so because it's a GUI based traffic analysis is easy, monitoring tools are there which simulates the traffic condition. When you change the topology also immediately the discovery happens through VBond, so adapts to the change very fast. These are the components of SD-Wan which we have seen: Vmanage, Vbond, vSmart, Vedge or C-Edge. Vedge or C-Edge. These are not normal edge routers. They are WebTele edge router, or it can be a CSR router or ASR router or ISR router which supports this feature. Not all ASR will support, depending on the license, depending on the version. The support may be there or may not there, you need to check. But there is support for SD-WAN on ASR, CSR, ISR. That's why we don't use the word V, instead we say Vmanager. Or because it is Cisco, you may call C-Edge also. I said no multiple networks. Across the multiple networks you can do traffic engineering. So you have internet, IP, you have MPLS, you have cellular. But the management plane, orchestration plane means management plane, the security guard device, which is an orchestration plane, the vSmart, which is a control plane, is one, even though the network is multiple. Vmanager is management plane, Vbond is orchestration plane, vSmart is control plane. Vmanage. We learned already what is Vmanage. It's a management plane, single management plane, centralized the provisioning. You can configure from one single place. You can configure here. What you want to configure here can be configured from here, from the Vmanager. Using netconf, it will be pushing the configuration down here. So it's a management plane, not the control plane. Centralized provisioning, central policy and templates. Yeah, it is GUI based. You got templates for various features. There's no command line needed here. GUI based. Centralized troubleshooting and monitoring. Software upgrade, if you want to upgrade, you need to just do it from here. No need to telnet or SSH to each device. All are centralized. So this is how Vmanager is used. It's a single pane of glass for centralized provisioning, central template and policy, centralized troubleshooting and monitoring, and for software upgrade. Next is Vbond. As I say, this is the one which authenticates. That's why it is called as authentication device. It is responsible for distributing list of vSmarts and vManage reachability to the WAN edge routers. So if the edge router is authenticated to the edge router, the Vbond will give the address of the vSmart and the Vmanager for reachability. So they all need to be in public actually. vEdge should be in public, Vbond should be in public. So we have finished 2 successfully. Now vSmart. We know this is the one which distributes the route information of one site to all other site. So vSmart is a vSmart distributes control plane information to WAN edges using overlay management protocol, OMP. All the policies of the data flow are defined centrally using Vmanager. So policy who decides? The management plane, the Vmanager. According to the policy, the routes are determined and distributed to the WAN edges using vSmart. That's why it is called as control plane. So hosting options, you can host it locally using VMs like ESXi or KVM, or you can also go for Amazon AWS, Microsoft Azure, Google Cloud, or Cisco Controller as Service, CCAS. Now the C edge or the WAN edge, which is the data plane. The WAN edge device communicates to vSmart first. It will communicate to Vbond. After authentication, it communicates to vSmart and the Vmanager. Let's read what is written here. vEdge device communicates to vSmart controller using OMP to set up the data flow. Yes. So the routes are distributed by vSmart, no? That's why it gives what all the route that it has got according to what the management plane has instructed through netconf. So whatever the vEdge provides to vSmart, vSmart will distribute to all other vEdges now. So this implements the data plane routing policy. This vEdge is also available in both virtual as well as physical. See, vEdges or WAN edge or C edge can be an ISR router, can be an ASR router, can be ESR router VMs, or it can be a separate vEdge device or ENCS 5000 series. Can be any of this. These are all different type of devices that we have in our network, Cisco network. Any one of this can be an edge device. Alright. So